Continuing to the next video. In the previous video, we have seen what is Archimedean property of R and density property of Q in R. So, using that, we are moving a little forward. So it says, okay, wait a second. So it says, as a result, it says for every real number, for every real x greater than 0 and every integer n greater than 0, there is only one positive real, there is only one positive real y such that y power n equal to x. So this is for every real for every real x greater than 0 and every integer n greater than 0, there is only one positive real y such that y power n equal to x. Okay, we shall directly begin the proof. Okay, so let x greater than 0, let x be a real number and x greater than 0. Now we shall go with the case when n is equal to 1. When n is equal to 1, the result is true because y itself is equal to x, because y power 1. If I take y is equal to x, then y power 1 is nothing but y, which is nothing but x. Hence the result is true. So let's take n is greater than 1 and let's consider a set. Let E is equal to set of all t belongs to R such that t greater than 0 and t power n is less than x. So we considered a set E. E is a subset of E is a set of all t belongs to R such that t greater than 0 and t power n is less than x. Now consider t is equal to x by 1 plus x. Now since x is greater than 0, 1 plus x is also greater than 0. So this implies x by 1 plus x, that is t, is also greater than 0. Now, okay, now x is less than 1 plus x. X is less than 1 plus x. Implies x by 1 plus x is less than 1. X is less than 1 plus x. If I divide by 1 plus x, it is x by 1 plus x less than 1. That is nothing but t is less than 1. So we got t is greater than 0 and t is less than 1. Now this implies t power n is less than t. This is by using a result. Okay, wait a second. This is by using the result whenever t belongs to R, for any t belongs to R with t is greater than 0 and less than 1, then t power n is always less than t for all n greater than or equal to 2, for every n greater than or equal to 2. So proof of this is left as an exercise. Now as you've seen, x is less than 1 by 1 less than 1 plus x. Similarly, 1 is less than 1 plus x. This implies if I divide by 1 plus x on both sides, it is 1 divided by 1 plus x is less than 1. Now this implies since x is greater than 0, using the property of ordered field, x by 1 plus x is less than x. That is nothing but, now this is nothing but t, so we got t is less than x. T is less than x. Now we have seen that t power n is less than t, therefore t power n less than t less than x implies t power n is less than x. Now clearly t is a real number, and t greater than 0, and t power n is less than x implies my this t belongs to E. Therefore E is a non-empty subset of R. E is a non-empty subset of R. Now if if T belongs to R is such that consider a real number. There's a T is such that T is greater than 1 plus x. Now 1 plus x is always greater than 1, therefore T is greater than 1. Now this implies T power n is always greater than C. This is also a result. That this goes like this. So for any T belongs to R, with t greater than 0, t power n is always greater than t for all n greater than or equal to 2. For all n greater than or equal to 2. So proof of this is left as an exercise. Okay, now so whenever I consider a real number t with the t greater than 1 plus x, then t power n is greater than t power n is greater than t. Now t is now this now from this again, t is greater than 1 plus x, but 1 plus x is greater than x, therefore t is greater than x. This implies t power n is greater than x. T power n is greater than x. Now this t is greater than 1, also therefore this t is greater than 0. T is greater than 0. So this real number t is greater than 0, but t power n is greater than x. But the elements of E are nothing but t belongs to R with the t greater than 0 and t power n is less than x. So this implies this t does not belongs to E. This t does not belongs to E because we consider t is greater than 1 plus x. So therefore for any t belongs to E, t must be less than or equal to 1 plus x. See, t when I consider t is greater than 1 plus x, we got t does not belongs to E. Therefore that means t belongs to E. There must be condition must be t must be less than or equal to 1 plus x. Now t is less than or equal to 1 plus x implies, that is, every element of E is less than 1 plus x implies my E has upper bound, or this 1 plus x itself is an upper bound of T, upper bound of E in R. Therefore E is bounded above in R, Thus E is a non-empty subset. So E is a non-empty subset of R, which is bounded above in R. Therefore E has supremum, because R has least upper bound property. Therefore E has supremum. Say supremum of E over R supremum of E over R is equal to y. Now elements in E are nothing but t greater than 0. Therefore this supremum must be greater than 0, that is y is greater than 0. So my claim is to show that this y itself is my required y, that is y power n equal to x. Y power n is equal to me. Suppose not, that is, suppose y power n is less than x. Because y power n is not equal to x means we have two cases: y power n is less than x and y power n is greater than x. We shall go with the first case, that is y power n is less than x. Then x minus y power n is greater than 0. greater than 0. Now this implies then there exists an h then there exists an h between 0 less than h less than 1 such that h is less than x minus y power n. X minus y power n. This is because see, this is because see, given any x greater than 0, x greater than 0, we have greater than 0, there is always an h such that there is always an h between 0 and 1 such that h is less than x. Now given that x is greater than 0, so we shall go with the two cases. Suppose x is greater than or equal to 1. Suppose x is greater than or equal to n, take h is equal to 1 by 2. Then clearly h is less than x. Suppose x is less than 1, but x is given that is greater than 1. Take h is equal to x by 2. Then clearly x by 2 is less than x, and that is nothing but h. Moreover, this h is less than 1 and greater than 0, because h is, that is x by 2 is nothing but x is between 0 and 1, therefore x by 2 is between 0 and 1. So using this result, there exists an h such that h is between 0 and 1 such that h is less than x minus y to the power n. X minus y to the power n. So we are rewriting this, that is h is less than x minus y to the power n. Okay, now okay, wait, so okay, now before continuing this, we shall observe one more result or one observation. We have b power n minus a power n is equal to b minus a into b power n minus 1 plus b power n minus 2 into a plus b power n minus 3 into a square plus so on up to b square into a power n minus 3 plus b into a power n minus 2 plus a power n minus 1. Now suppose assume that 0 is less than a less than b. 0 is less than a less than b. Then 0 is less than a power n less than b power n. So this is also a result. You can verify this or take it as an exercise. Now whenever a less than b, 0 less than a less than b, then a 0 less than a power n and less than b power n. This is true for all n. Okay, now using this result, now observe b power n minus 2, sorry, observe a is always less than b. Now multiply this by b power n minus 2. Now we know that b is greater than 0, therefore b power n minus 2 is greater than 0. So when I multiply this, we get b power n minus 2 into a is less than b power n minus 1. Because it is b into b power n minus 2, that is nothing but b power n minus 1. Similarly, observe this. A is less than b implies a square is less than b square using this result. Now again, a power b power n minus 3 is greater than 0 because b is greater than 0. Now this multiplying to this relation, we get b power n minus 3 into a square is less than b power n minus 3 into b square, and this is nothing but b power n minus 1. This we observe that each term in this sum is less than b power n minus 1. Therefore Therefore each sum. Now observe there are n minus 1, n minus 2, n minus 3 and so on up to n. So there are n terms, that is we get b power n minus a power n is equal to b into a. Is now we see that this each term is less than b power n minus 1. So there are n terms where n into b minus 1, n into b minus 1, b power n, sorry, n into b power n minus 1, n into b power n minus 1. So now using this observation we have okay, we have y is greater than 0. We have y is greater than 0, and h is also greater than 0. H is a number which is greater than 0. So y is greater than 0. Now this is always less than y plus h. Now using this whenever a and b, a less than b and b, 0 less than a less than b, we got b minus a, b power n minus a power n is less than b minus a into n into b power n minus 1. Now using this observation here, we get y plus h power n minus y power n is less than, now this is b, this is a, so it is b minus a, that is y plus h minus y into n into b power, that is y plus h power n minus 1. And if you observe, this is nothing but y plus h minus y, so it is h into n into y plus h to the power n minus 1, n minus 1. Now y plus h to the power n minus 1. Now y plus h is always less than y plus 1, because h is less than 1. So y plus h is less than y plus 1 implies, now moreover this is greater than 0, also h is greater than 0. Now implies y plus h to the power n is less than y plus 1 to the power n. Now this implies this is less than y plus h to the power n minus 1 is less than is less than h into n into y plus 1 to the power n minus 1, 1 minus 1. Now in the above, let's go back. Now observe, given any x greater than 0, we can find an h between 0 and 1 such that h is less than x. Now x minus y power n is greater than 0. For this x minus y power n greater than 0, we used h between h. Now particularly now in particularly x minus y power n into divided by y n into y plus 1 to the power n minus 1. Now y is greater than 0, y plus 1 is greater than 0, y plus 1 to the power n minus 1 is greater than 0, and n into y plus 1 to the power n minus 1 is greater than 0. Therefore this real number is greater than 0. Okay, so we are using the same result for this. We get x minus y power n divided by n into y plus 1 to the power n minus 1 is greater than 0. So there exists an h satisfying h is less than x minus y power n into n divided by n into y plus 1 to the power n minus 1 to the power n minus 1. Now we got so rewriting this, we have h is less than x minus y power n divided by n into y plus 1 to the power n minus 1. Now if you observe this n into h, y plus 1 to the power n minus 1, that is this is less than x minus y to the power n, that is we have y plus h to the power n minus y power n is less than x minus y power n. This implies y plus h to the power n is less than x. Y plus h to the power n is less than x. Now y plus h is a real number greater than 0 such that y plus h to the power n is less than x implies this y plus h belongs to E. Y plus h belongs to E. But what you know about y? Y is an upper bound of E. Y is an upper bound of E and y plus h is an element of E. Therefore, y plus h is less than or equal to y. Y plus h is less than or equal to y. But we have y is greater than 0 and h is greater than 0. Therefore y plus h must be greater than y. Y plus h must be greater than y. Y plus h is greater than y. This contradicts the fact. Therefore we cannot have both. Therefore y, my assumption y power n less than x is not true. It is not true. So we shall go with the next case. Suppose y power n is greater than x. Y power n is greater than x. Suppose y power n is greater than x, then as you seen in the previous, y power n minus x is greater than 0, y power n minus x is greater than 0. Take k is equal to y power n minus x divided by n into y power n minus 1. Now this implies n into y power n minus 1 into k is equal to y power n minus x. Now clearly this is k is greater than 0. Consider k minus y, which is equal to y power n minus x divided by n into y power n minus 1 minus y, which is equal to if you solve the this will be 1 minus n into y power n minus x divided by n into y power n minus 1. Now 1 minus n, since n is greater than 1, 1 minus n is less than 0. So if you observe, and y minus y power n is also y power n is greater than x, so you get this is less than 0. That means we got k minus y is less than 0. That is, therefore y minus k is greater than 0. Consider any real number t belongs to t. Consider any real number t with t greater than y minus k. Now since y minus k greater than 0, now this is a greater than b greater than 0. This implies a power n, that is e power n greater than y minus k to the power n, which is greater than 0. Now this implies minus t power n is less than minus of y minus k to the power n. Now which implies y power n minus t power n is less than y power n minus y minus k to the power n. Now again using the previous observation, this is always less than y minus k into n into y power n minus 1, and this is nothing but k into n into y power n minus 1, k into n into y power n minus 1, and that is nothing but y power n minus x. That is nothing but y power n minus x. So we got y power n minus t power n is less than y power n minus x. This implies minus t power n is less than minus x, and that is t power n is greater than x. Therefore for any real number t with the t greater than y minus k implies So for any t belongs to R with the t greater than y minus k implies t power n greater than x. This implies t does not belongs to E, because to belongs to E, t power n must be less than x and t greater than 0. Now this implies here t greater than 0, but t power n is greater than x. This implies t does not belongs to E. Therefore t belongs to E implies t must be less than or equal to y minus k. T must be less than or equal to y minus k. This implies every element of E is less than or equal to y minus k. Therefore, y minus k is an upper bound of E in R. What do you know about y? Y is a least upper bound. Y is a least upper bound of E in R. Now, what's the relation between y minus k and y? Y minus k is less than y. This implies y minus k is the least upper bound, which is a contradiction to the fact that my y is least upper bound. Y is least upper bound. Therefore, my assumption y power okay, wait. Therefore, my assumption y power n greater than x is also false. This also false. Hence my claim y power n equal to x. Y power n is equal to x. Now we got so for the real number x greater than 0 and an integer, we got a positive real number y. We got a positive real number. We got a positive real number. We got a positive real number y, such that y power n equal to x. Now we shall show that there is only one such positive real number. Suppose there are more than one. Suppose there exist y1 comma y2 belongs to R with y1 greater than 0 and y2 greater than 0, such that y1 power n equal to y1 power n equal to x, and y2 power n equal to x. Y1 power n equal to x and y2 power n equal to x. Now since y1 and y2 are in real numbers, and we must have y1 using the trichotomy, we must have y1 is less than y2, or y1 equal to y1 is equal to y2, or y2 is less than y1. Suppose they are not equal. We are going with the same thing. So then y1 must be less than y2, or y2 must be less than y1. Say suppose y1 is less than y2 without loss of generality. Now but we know that both y1 and y2 are greater than 0. This implies y power n y1 power n and y1 power n is less than y2 power n. A less 0 less than a less than b implies 0 less than a power n less than b power n. So that's y1 less than y2 y1 y2 are positive real, such that y1 less than y2 implies y power n less than y2 power n. And what is this? It is nothing but x. What is this? This is also nothing but x. This implies x is less than x, and it is not true. It is not x less than x. It is not possible. Therefore the existing y is always unique. That means y1 equal to y2. That means there is always only one positive real y, such that y power n is equal to x. Hence the result. So it says for every real x and every integer n greater than 0, there is only one y positive real y, such that y power n is equal to x. Y power n equal to x. And this y is called nth root of x, and this y is called nth root of x. It's called nth root of x. It's called nth root of x, and we denote y is a we denote this we denote this y is equal to nth root of x or x to the power 1 by n, x to the power 1 by n. Thank you.